Picture the scene. It's a dark and stormy night on Isla Nublar. A character is trying to escape. Suddenly, a small, curious dinosaur appears. It chirps and coos, tilting its head. It seems friendly, almost cute. Then, everything changes in an instant. A large, colorful frill unfurls around its neck. It hisses and spits a stream of black, tar-like venom directly into the character's eyes. This is the Dilophosaurus from the movie Jurassic Park. It's a terrifying and unforgettable movie monster. This single scene cemented the image of Dilophosaurus in the minds of millions. It became one of the most famous dinosaurs overnight, known for its small size, known for its neck frill, known for its deadly venomous spit. This depiction is powerful and dramatic. It's incredibly effective for a blockbuster film. The problem is, almost everything about it is completely wrong. The real animal was nothing like the creature we saw on screen. The movie took enormous creative liberties, inventing abilities, shrinking the dinosaur for dramatic effect. For decades, this fictional version has overshadowed the true nature of this fascinating predator. The movie's creators, including Steven Spielberg and author Michael Crichton, made a deliberate choice to craft a memorable monster. But in doing so, they created a legend with little basis in scientific reality. The result is a massive gap between public perception and paleontological fact. The truth is often more interesting than fiction. That is certainly the case with Dilophosaurus. We are going to peel back the layers of Hollywood myth-making. We will journey back in time to the Jurassic period, and to the moment these incredible fossils were first unearthed. We will explore what the bones actually tell us about this animal. There was no neck frill. There was no venom spit. This dinosaur was definitely not small. The real Dilophosaurus was a large, powerful predator at the top of its food chain. It was one of the first truly giant meat-eating dinosaurs to walk the earth, a far cry from the small ankle-biter in the movie. In this video, we will embark on a myth-busting journey. We will replace the fiction with fascinating facts, all backed by the latest scientific research. We'll look at the discovery of its fossils. We'll understand its true size. We'll investigate the real purpose of the twin crests on its head. We'll examine its powerful jaws. We'll examine its arms to figure out what it really ate and how it hunted. Was it a lone hunter? Did it live in packs? How fast could it run? By the end, you will have a completely new and accurate picture of this incredible Jurassic legend, separating the science from the silver screen fantasy once and for all. So, what was the real Dilophosaurus actually like? Let's set the stage. Early Jurassic, around 193 million years ago. This is long before giants like Tyrannosaurus rex, Allosaurus. Dilophosaurus was one of the largest land predators of its time, a true apex predator in its ecosystem. Forget the small creature from the movie. The real animal was about 6 to 7 meters long, roughly 23 feet. It stood as tall as a person at the hips. It would have weighed around 400 kilograms, nearly half a ton. A formidable, powerful hunter that dominated its environment. Not a flimsy neck frill. Its most striking feature was something different. A pair of thin, bony crests along the top of its snout. Dilophos, 2 crests, the meaning behind its name. These crests were likely fragile, not for fighting, more likely used for display. Imagine them brightly colored, to attract mates, or to intimidate rivals. Its real signature, stunning, natural ornamentation. The body was built for predation. A theropod, the 2-legged, mostly meat-eating group that includes T-Rex, Velociraptor, a long tail for balance while walking or running. Arms that were relatively long and strong, not tiny. Each hand had 3 powerful fingers. Each finger ended in a large, sharp claw. These claws weren't just for show, serious weapons. Essential for grasping and tearing prey. A hands-on hunter. This video will be your complete guide. We start with its discovery in the Arizona desert. Then a deep dive into its anatomy. Evidence for size and shape. Analyze the function of its famous crests. And its surprisingly delicate jaw. Debate its diet. Scavenger. Hunter of large prey. Or a specialized fisher. Finally, examine evidence for its speed, its power, and its social life. Prepare to meet the real Dilophosaurus. far more impressive than any movie monster. Our story begins in the summer of 1940, not in a lush Jurassic jungle, but in the harsh, sun-baked landscape of northern Arizona. A small team of paleontologists from the University of California, Berkeley, was exploring the colorful rock layers of the Kayenta Formation. This area is part of the Navajo Nation, and the expedition was led by a man named Charles Camp. They were searching for fossils that could help them understand the ancient ecosystems of the early Jurassic. The work was difficult, involving long days spent scanning the ground under the intense desert sun, hoping for the telltale glint of fossilized bone weathering out of the rock. It was a painstaking and often unrewarding process, but the potential for a major discovery kept them going. The expedition's luck changed dramatically thanks to a Navajo man named Jesse Williams. Williams knew the land intimately. He had previously found interesting fossils in the area and led the Berkeley team to a specific site near a place called Tuba City. There, weathering out of the sandstone, were the bones of a large animal. The team was immediately excited. This was clearly a significant find. The bones were articulated, meaning they were still connected in their life positions, which is a rare and valuable occurrence in paleontology. It suggested the animal had been buried quickly after it died, before its skeleton could be scattered by scavengers or the elements. The team began the slow and delicate process of excavation, carefully chipping away the surrounding rock, exposing more and more of the skeleton. They uncovered parts of the legs, the hips, a long string of vertebrae from the backbone, and of the tail. It was clear they were dealing with a large, two-legged predator, a theropod dinosaur. However, the skull, the most important part for identifying a new species, was badly crushed and incomplete. The sheer size of the bones alone told them this was one of the largest meat eaters known from this early period in dinosaur history. After weeks of hard work, the team managed to excavate the entire specimen. They carefully wrapped the fragile bones in plaster jackets, protecting them for the long journey back to the University Museum in California. Back in the lab, the real work of cleaning and studying the fossils would begin. This initial discovery was just the first piece of a puzzle that would take decades to fully assemble. The bones found by Jesse Williams and Charles Camp's team would eventually become the foundation for our understanding of a brand new and soon-to-be famous dinosaur. The desert had given up one of its most impressive secrets. Once the fossils arrived at Berkeley, the painstaking work of preparation began. Technicians and paleontologists spent countless hours meticulously cleaning the rock away from the bones. This specimen, catalogued as UCMP 37302, was clearly a significant find. The paleontologist assigned to study it was the renowned Samuel Wells. Wells examined the skeleton and compared it to other known theropod dinosaurs. Based on the available evidence, particularly the incomplete and crushed skull, he noticed similarities to another large predator from a different part of the world, Megalosaurus. Megalosaurus, first named in the 1920s, was one of the very first dinosaurs ever discovered. It had become something of a wastebasket taxon, a category where many poorly understood large theropods were placed. Wells concluded that the new Arizona dinosaur was a new species of Megalosaurus. In 1954, a full 14 years after the initial discovery, he formally named it Megalosaurus wetherilli. The specific name, wetherilli, was chosen to honor John Wetherill, a local trader and explorer who had provided immense help to the expedition in the Kayenta region. At the time, this classification made sense. The skeleton showed the general characteristics of a large theropod, and without a well-preserved skull to highlight its unique features, placing it within the broad category of Megalosaurus was a logical if conservative choice. The world now knew of this new Jurassic predator, even if its true identity was still hidden. This initial classification, however, was temporary. It was based on incomplete information. The most distinctive features of the animal were simply not visible in that first specimen. The crushed skull gave no hint of the delicate structures that sat on top of its snout. The name Megalosaurus Wetherilli, served its purpose by putting the animal on the scientific map, but it failed to capture what made this dinosaur truly special. It was like describing a peacock without mentioning its tail feathers. The animal was mislabeled, filed away under a familiar but incorrect identity, waiting for a new discovery to reveal its true face to the world. For a decade, the dinosaur remained known as a species of Megalosaurus. But paleontology is a science of new discoveries, and a single new fossil can change everything. The next chapter in this dinosaur's story would require another trip back to the Arizona desert, and another find that would force a complete reevaluation of this magnificent creature. The name Megalosaurus would soon be shed for a much more fitting one. The breakthrough came in 1964, and, well, Samuel Wells returned to the very same area in the Kayenta Formation, where the first skeleton had been found 2 decades earlier. He was hoping to find more fossils that could shed light on the anatomy of Megalosaurus wetherilli. Incredibly, he succeeded beyond his wildest expectations. He located a second specimen, just a few hundred meters away from the original discovery site. This new skeleton, catalogued as UCMP 77270, was even more complete and better preserved than the first. Most importantly, it included a nearly perfect, uncrushed skull. This was the paleontological equivalent of finding a Rosetta Stone. As Wells and his team carefully prepared the new skull back in the lab, a stunning and unique feature emerged. Running along the top of the snout was a pair of delicate, semicircular crests of bone. They were thin and fragile, and it was immediately obvious why they had not been recognized in the first crushed skull. This was a feature unlike anything seen on Megalosaurus or any other known theropod at the time. It was a clear sign that this dinosaur was not a species of Megalosaurus at all. It belonged to its very own, distinct genus. The new skull was the key that would unlock the animal's true identity. With this new and definitive evidence in hand, Wells knew he had to rename the dinosaur. In 1970, he published a new paper correcting his earlier work. He proposed a new genus name, Dilophosaurus. The name is derived from Greek combining di meaning two, lophos meaning crest, and sauros meaning lizard. It translates perfectly to two-crested lizard, a name that beautifully and accurately describes the animal's most remarkable feature. The species name Wetherilli was kept to continue honoring John Wetherill. Thus, Megalosaurus wetherilli officially became Dilophosaurus wetherilli. The legend was finally born, with a name that matched its unique anatomy. This act of renaming was a fantastic example of the scientific process in action. An initial hypothesis, Megalosaurus, was proposed based on the available evidence. When new, better evidence, the second skull, came to light, that hypothesis was tested, found to be incorrect, and replaced with a new one, Dilophosaurus. Wells was not afraid to correct his own work in the face of new data, a hallmark of a great scientist. The discovery of the second specimen and the subsequent renaming cemented Dilophosaurus's place as one of the most distinctive and fascinating dinosaurs ever found, finally giving it the unique identity it deserved. Section 1. The Legend, the Lies, and the Lizard. We began with a familiar fictional image, the small, frilled, venom-spitting monster from Jurassic Park. Over this deep dive, we dismantled that Hollywood creation piece by piece and replaced it with a far more impressive, scientifically accurate animal. The real Dilophosaurus was no movie monster. It was a true giant of the early Jurassic, an apex predator that dominated its ecosystem 193 million years ago. Standing as tall as a man at the hips, stretching over 20 feet long, weighing nearly half a ton. The small size was a fiction invented for the film. The two most famous movie features are complete myths. The dramatic, unfurling neck frill. No fossil evidence supports it on Dilophosaurus. The neck bones show no signs of the required supports or attachments. The ability to spit blinding venom. Pure speculation with no anatomical basis. The skull was strong and capable, but shows none of the glands or grooved teeth linked to venom delivery. Both the frill and the spit are 100% fiction. The real signature? A magnificent pair of bony crests. Fragile, lightweight, likely for visual display, attracting mates, recognizing its species, intimidating rivals. Crests, perhaps covered in brightly colored keratin. The dinosaur's true calling card. Its body was a formidable weapon system. Powerful legs, up to 25 miles per hour. Long, muscular arms with 3 large, sharp claws for grappling. Specialized jaws for deep slashing bites. Versatile killer, likely a hunter, scavenger, and even a fisher. So, as we close the book on this incredible animal, remember the real Dilophosaurus. Not the pint-sized movie monster, but the trailblazing giant. One of the first theropods to achieve massive size, successful and adaptable. Its story shows how science refines knowledge and corrects myths. The truth is far more fascinating than the fiction. If you enjoyed this journey, like, subscribe, and tell us which dinosaur myth to bust next. Final comparison.